guess the 5th day of the conference. And this is going to be a workshop on data analysis for marine observatories. We have a full day ahead of us with 6 speakers. For the beginning, let me introduce myself. I'm Roee Diamant. I'm a professor at the University of Haifa, and my expertise is in underwater acoustic signal processing. We also do some small robotic stuff, but mainly the focus is on applications concerning detection, signal processing, for classification, underwater communication, networking, localization, tracking, these kind of stuff. And I also happen to have an observatory of our own. It's called THEMO. It's a collaboration with Texas A&M, so that's how I got into the marine observatory business. It's been hanging around for 6 years now. In my talk in the afternoon, I guess I will show some details for it. Just at the beginning, I want to share some thoughts of why do we need observatories. And the main reason is we need data. And we need the data to be very diverse and very long-term, so what we call time series. And the idea of a fixed observatory is that you put a sensor or a set of sensors usually in a single location, and then you track things that evolve over time. That is usually years. In my case, my observatory is 6 years. There are some observatories that have been around for 30 years. So then, because it's a single spot, you can really see phenomena, how they change during course of seasons, of years, decades, etc. Then you can learn things about global warming or differences to the salinity of the ocean. And you can really compare stuff. So that's the point about long-term data collection. Then when you put in an observatory, you are less interfering the environment. It gets used to it. It actually becomes part of the environment in a way. If you put in an observatory that is offshore, it's usually a shadow point, and there are small fish that go there because it's a point at the sea, and then it becomes like a system by itself, and then you can track and see how it evolves over time. So there's a big dispute if you want to put stuff like wrecks at the sea to enrich the environment, or does it really interfere? But in case of observatories, it's usually just a buoy with a cable, nothing really harsh. Much harsher would be if you go there with a ship all the time. That is more interfering from my perspective. Then if you have an observatory, as I mentioned, you probably want to put in several sensors, so you get quantity of not just data over a long time, but also diversity in terms of the phenomena that you observe. So you can put in water current measures, you can put in salinity, temperature, humidity, explore things that cross the different layers of the sea at the depth and at the surface and above the surface. And then you can link things, and we'll see how this stuff help to really understand different complex phenomena in our speakers today, with our speakers today. So when you have observatory, you can correlate between the data set, you can understand relations. If you have several observatories in different locations, you can compare data between them and then check trends of the data. One of the things Nuno and I are planning to push is standardization, and we see that the standardization of the data, and we see that as a major gap towards the sharing of data between observatories, and definitely this is something that is needed in recent years, that we see a boom with the number of observatories out there. There are several types of observatories. There can be a fixed observatory, what we call an anchored observatory. It it doesn't have to be a small buoy, like in the left-hand corner, up left-hand corner, you can see an example of an observatory that is in the Sanish Inlet in Vancouver Island, Canada. They have a ring, and inside the ring there's a lot of sensors. I think they have like 200 different sensors there, and this thing is anchored at several locations, so it is really fixed and rigid and can withstand harsh condition, but it's a point at the sea. There can be also platforms that you see at the bottom. That's the Plukan platform that is in the Canarian Islands. And that is actually a large concrete building that goes all the way down to the sea. And it's a lab by itself. There are researchers who go there and they walk at the sea doing real-time measurements. So in this case, it gives you this capability, of course, because it's a fixed system. It cannot be far away from the sea. In this case, it's only 1 kilometer offshore. There are also mobile observatories. And here you need the quantity. So the Argo floats has been very successful. That's a mechanism. It's basically a floater that can submerge and go up and down according to some plan that you give it, and collecting data. The number of sensors that you can put on it is not large because there is an energy issue. As soon as it surfaces, it transmits the data via satellite communication. And there has been tens of thousands of Argo floats that were released at sea. So the picture over here that I show, the map, the globe map, is from 2011, and you can already see that the Argo floats are basically everywhere. So that, from this way, contrary to what we said before about the fixed observatories, the mobile observatories will give you also the spread of the data, so you can see spatial relations across time. There are also floating buoys. Also here, this belongs to Plukan. These are buoys with sensors, but they just float. They don't stay in the same location. They're not anchored, and that again gives you both a time series, because you can maybe limit where it's going, and it gives you the spatial resolution. And there is undersea platforms. For example, the one at the bottom belongs to the Neptune network from Ocean Network Canada, and that is an observatory that is actually shown here in the map on the right-hand corner, that stretches some hundreds of kilometers away in a loop with about 20 different stations like this one that is sitting at the bottom of the ocean. This one is, for example, at 2,000 meter depths. And you got cable, optical fiber that gives you access to all the data in real time, and this is indeed a big infrastructure. Anchored mooring would show like this. It can be tethered mooring. There's a buoy, and there's sensors that go all the way down. Some cases, these sensors will be standalone, and the data would just be stored inside, and then you go there once every few months or a year and collect the data. And in some cases, the data is actually shared up with the buoy and then transmitted to shore via usually RF connection. So here are examples of observatories in the world. We talked about Ocean Network Canada. There is the EMSO network, that's the European one. It has many observatories. Most of them are anchored buoys. Then there is the TABS system that is in the Gulf of Mexico. They have about 30 anchored buoys that share information between them and route data. And then there is the famous Mbari observatory that is also a cabled observatory. It's a really nice one. Okay, so what do we do with the data once we collect it? Well, first of all, we need to check the quality. It's very important because if we want to learn things out of the data, we need to be assured that this data is good. This is another problem that is kind of an aim of our workshop, is to find how to actually identify or measure the quality of the data. So we would find anomalies, we would reveal statistics of the data, and we want to validate the data. Sometimes it's automatic, sometimes it involves also an expert. We want to look at trends of the data, so periodic phenomenons that we can observe using, for example, cyclostationary analysis or some spectral analysis or template matching. There are many options. Relations between the sensor, it doesn't have to be simple correlation because usually these relations are not linear. So here machine learning kicks in really hard. And then temporal and spatial relations where you observe, again, periodicities or trends across different time zones. So across a day, you want to look at the tide or the plankton, how it goes up and down. You want to look at seasons, how the temperature is changing, or year, salinity, for example. In our case, in the Mediterranean, we can see a trend over only 6 years. We can see a trend of the temperature as it rises, and we all know that the Mediterranean is fastly warming up. And then across observatories, we can also see phenomena. We can process the data on board. That's the hard part. Usually you do that if you have lots of data that you cannot download every time and you want it on time. So you will put in processors on the buoy itself, have some solar panels like here that will provide you with power. You can put in all the data in some sort of a server and allow your users to put their algorithms on it using, for example, Sandbox. This way they don't have to download the huge amount of data. In my case, over 6 years, I collected more than a picobyte of data. So it's really hard to actually share it with people. You cannot really move it around. So we use the Sandbox as a system to do that. You can also put smaller amounts of data on a cloud server and allow people to use it. And sometimes there is no choice but to actually have hard disks and send them over. The new Starlink system may solve that problem. They guarantee 100 megabytes per second from everywhere using a satellite, about $100 per month. So should be, maybe would solve that problem. Then last is how we analyze in terms of statistics. So we usually look at distributions. I can tell you that nothing is really Gaussian. So we need to actually find out the distribution that drives the data. I mentioned cyclostationary analysis. Modeling a data simulation is very important because this way we actually learn from our data. So that was a brief introduction to kind of data processing that we do from observatories. And here is an outline of the workshop. So Nuno would follow up next with an introduction in terms of the need for standardization. Then we start in the first session, which will be about mobile observatories, and we'll have Susana Barbosa from UNIZG-FER that will give us a 45 minutes talk about management issues of the data. We like to have in each one of those sessions an open discussion so that people can share their own experience, ask questions, and see how we can advance things according to topics. So the first topic would be about dissemination of data. How can we push that? Then hopefully we'll have a coffee break. And the second part would be a standardization of the database. I will give a talk about quality assurance, algorithms for quality assurance, and then we will give a talk about how we can calibrate, in-situ calibrate the sensors. And again, the open discussion will be how can we drive standardization in terms of data processing. Sorry, in terms of quality of data. The last session would be fixed observatories, and we'll have 3 speakers. We'll have Georgios Silios, and he will give us a talk about the Odyssea, which is a EU project that tries to link different observatories across Europe. Ayal Azar from the Israeli Oceanography IOLR, it's an oceanography and limnological research institute. She has an observatory that is called DeepLab, and she will show some findings from it. And then we'll have Steve DeMarco joining us from Texas A&M University, and will give a talk about the discoveries from THEMO, the observatory that I mentioned before. We'll wrap up with a discussion about the challenges, how can we collaborate between different observatories. So we hope that you will enjoy it and find out new things, and also share your own experience. So I'll give the stage to Nuno.